The Intel RAPL technology is able to estimate the energy consumed by various domains of your system. It provides several ways of accessing this information. In this module, I'm going to discuss two of them, the sysfs interface and the perf event interface. Let's start with the sysfs interface. This interface should be familiar, as it has been covered in previous modules. Power cap zones provide ways of monitoring energy consumption. In the case of Intel RAPL, a file with the name energy_uj is available for this purpose. This file, upon reading, provides the amount of energy consumed by the zone from an arbitrary point in time from the past in microjoules. That's the reason behind the uj suffix. Notice that I need superuser privileges to access this file, as this information may be used to perform a security attack. Let's now see how this value changes. In order to monitor the energy consumption, I'm using the watch utility, which allows me to execute a command periodically and see its output. In my case, I want to read the file every 1/10 of a second. When I run this command, I can see that the energy increases. Let's now try measuring the idle energy consumption of my computer. In order to do so, we need to record the value of energy uj in 2 points in time and take into account the time difference. I will use the sleep utility to wait a specific amount of time between measurements. First, we read the value of energy uj, sleep for 5 seconds, and then read the value again. Let's execute it and wait 5 seconds. These two values represent the energy consumed since an arbitrary but fixed point in time. By taking the difference between these values, we can calculate the total energy consumed during the measurement period. We can divide it by 1,000,000 to get the energy in joules. And then divide the value by the number of seconds to get the average wattage of the processor during the measurement period. In this case, the average wattage is around 120 watts. When measuring energy consumption using the energy counter, it is important to take into account the possibility of counter overflow. When the counter reaches a predefined maximum value, it will be reset to 0. Let's see this in action. The maximum value of the counter is specified by the file max_energy_range_uj. The second way of measuring energy consumption is through the perf event interface. The perf utility provides an easy way of using this interface. Making a measurement is as easy as executing perf stat with several options. First, we need to specify the event we want to gather statistics about. The command perf list provides a summary of all available events. In my case, the only two events are power/energy-cores and power/energy-pkg. These two events relate directly to the power cap zones from the sysfs interface. We can select one or more events for a single invocation of perf. The second parameter passed to perf is the command to run. Usually, perf gathers information related to the executed command, but in the case of power consumption, it does not differentiate between programs and always reports the total energy consumed by the zone. So in order to measure the idle energy consumption, we can pass the sleep utility as the command. Let's execute this command and wait. When the command finishes, we can see that perf automatically summarized the energy consumed in joules. When dividing the energy in joules by the number of seconds, we can see that the average wattage is around 120 watts, which is similar to the value reported by the sysfs interface.